All right, so today we're gonna go over how to build a in-memory cache for Warp, and the reason why I'm doing this is because I'm working on a personal project where the underlying API that I'm going to use has a limit, a daily limit. I'm trying not to go over that, so I thought one of the easiest ways to not go over that limit is to implement a cache system. So yeah, here we go. All right, so let's start off by looking up what cache is. I went to Wikipedia. This is cache computing from Wikipedia. In computing, a cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. They continue by talking about some of the terminology around cache, which is a cache hit occurs when the requested data can be found in a cache, while a cache miss occurs when it cannot. More or less, from a high level, a cache is typically a key value store, and you put it right in front of your endpoint. So let's say person A comes in, they make a request. You check the cache for the key to see if there is already a value for that request. If there is a value for that request, then you just serve them that value. If there is not a value for that request, then you hit your actual endpoint, you do the computation, you come back with the value, you store that value in the cache, and you return that value to the user. And the reason why you store that value in the cache is so that if somebody else comes in the future and asks for that same information, you can then pull it from the cache and serve that to this new person. All right, so earlier I mentioned that the reason why I'm doing this project to begin with, at least this cache, is because I'm using a service that has a daily limit. And this is the service I'm using, OMDB API, which is a RESTful web service to obtain movie information. All right, so I'm going to walk through at least the cache of how I went about implementing one, and then I'm going to show you how I integrated it into Warp. So let me start with the cache itself from a high level. I have a struct. I name it cache. The cache has items. I have the items being stored as a hash map, which is just going to be the key. And then the item, the value, right, which is going to be the cached item. And then I have size here. And the reason why I have size is because the way I'm going about implementing this cache is that it can only hold a certain number of items. And once it hits that number of items, it's going to drop the oldest item that is in the cache. So coming down here, some of the methods I have on this cache, I have a new, just creates a cache. I have new app cache, and the reason why I have a new app cache is because when you're writing a cache for a web service, which is going to be running concurrently, then you have to make sure that the cache can be used in a concurrent manner. In order to do that, you have to use, or at least I used, arc and mutux, and then I passed the cache inside of those things. And then here's my type alias for that, so I don't have to write it out. So let me scroll up and show you that real quick. Public type app cache, and it's a arc mutux cache. All right, moving onward. One of the main methods I have is called check. I'm going to check to see if an item is in the cache. I do that by looking at self.items get, passing the key, and if it returns something, then I know it's there. And if it does not return something, then I know it's not there. Before I move on, let me explain the option. So the return value I have here is X, which is item that was returned back, result, and then clone of it. And it's going to be cloning a 30 JSON value, as in, if we go back up a little bit, here are the items. This is a cache item. What do my cache items entail? They have a date and a result. I have a date there because I need to know which one is oldest and which one is newest. and the result I'm holding as a JSON value. The reason why I'm doing that is so that this cast can be used for my current endpoint and other endpoints in the future, as long as the return value from my computation is serializable and deserializable. This should work. So I'm kind of happy with that. So coming back down, so I'll explain this, going to add. So just a quick heads up, my add is doing two things. It's adding something to the cast items list or task map, and it is also going to be dumping, like if I'm over the limit of how many items I can hold, it's going to be releasing or dropping the oldest item. Oh, so let's look at the function signature. So I have add, I have a generic T, and the generic T implements SERDI serialize, as in the item that I pass in for T has to be serializable. The reason why it has to be serializable is because the cast items that I'm storing them as JSON objects, and JSON objects, I just need to be able to serialize it to JSON. So moving onward, mutable self, because I'm modifying self. Here is the key that I'm going to use to store things, and here is the T that is going to be a serializable object. I also have a option to return. So option cast return. The reason why it's an option is because every add is not going to result in something being dropped from the cast. And then cast return. Let me show you what that looks like real quick. Here it is. So cast return is just going to be the key that was dropped and the cast item that was dropped. All right, so let's go through this real quick. All right, so I start off the method by defining my default return, which is going to be none. And then I do the insertion into the cast, right? So here's the key, and then here's the cast item, which I have my date, which is going to be UTC now, just so everything is comparable. And then here's the result, which is going to be a JSON value. So I'm using SERDI JSON macro to serialize the object, which is the result that was passed in. And then I have a big chunk of things trying to enforce the size limit. More or less, if the items, the length of the items, so the size of the hash map, is greater than the size that I want it to be, then I'm going to iterate over the items, and I'm going to more or less find the one that is the oldest. There was probably a better way of going about this, but I was pretty hacky about it. Well, not necessarily hacky, explicit. What I did explicitly here was I set the default for the return key and return value to be none. Then when I did the iteration, if the return value is currently none, then I'm going to set the return key and the return result. If it is not none, then I'm going to compare it to the value that I'm currently iterating over, compare the dates, and if the value that is currently stored date is greater than the value that I'm looking at, I am going to set the new key and new value to be these current items. So after that is done, I will have a result key and a result value that I can just start dumping. Well, that needs to leave my cache. So if the result key is sum, unwrap, get the key, and then for self.items, I'm removing it from the hash map. So I get the value, and then I'm setting my return value, which is sum, cache return, key and value, and then I'm returning that. So just be more explicit. This is the line that removes it explicitly from the cache. And then this is just me setting up my return. So that's more or less it. I have some tests down here, but I don't think we need to go through those. So now, next, I want to show you how I incorporated that into my application, my Warp application. And just as a heads up, this is very similar, almost identical to the Warp to do. So if you go to Warp, right, and you go to their examples and you look at their to do example, to do's RS. In this example, they have an application which is sectioned into modules. So we have our filters, we have our handlers, and we have our models, right? And what they do in this application is they have a DB, which is not an actual database, but more of something that is being stored in memory locally. And let me show you that real quick. Blank DB returns DB. DB is a type alias for arc, mutux, and then here's their database, a vector of to-dos. And what they have to do is be able to pass this DB from the main scope where the application is served all the way to the handlers where the DB is actually going to be used. So in here, what they do is create their DB here. They pass it to filters to do. Come down to filters, filters to do. Filters to do passes that to filters to do list. Filters to do list, which has the warp code, is what passes it to the handler. Now, if you note here, this handler isn't being called explicitly here. It's just a reference to it. However, this handler knows what item is going to be sent to it. And the way they did it was by making sure that DB is passed through to the handler using an and a with DB. And the with DB, scrolling down here, is them creating their database into a filter that can subsequently get passed to their handler. So implements filter, extract, the type, DB, error, can't fail, plus clone, warp any move, and then passing the DB clone. And explicitly, let me go to the handlers just so you can see it. Here's handlers list to do's. Let me scroll down. Handlers list to do's, and we see that it takes their options and their DB. So this example shows you how to successfully pass in information from your main scope all the way down to your handler so it can be used there. And let me go to my source code. My main file is here. Let me scroll down. Here's the cast that we went over, just importing it. And then right here is where I create an instance of the cast that is wrapped in an arc and a mutux. And then I pass the cast to my API register. So let me go to that. So source, API, RS. And then here's the register function, which has the cast. And then in here, you see that I'm passing the cast to my routes OMDB register function. All right, so I'm just passing it along down the line. And this is my routes OMDB file. So in here is the OMDB register that we saw, and it has the appcast. And then in here, I'm doing the and with cast appcast. And the with cast is identical to the one that was in the to-dos, where we do with cast, we pass in what we want to pass in. We implement the filter, we extract, and I put the type, and the error, which is it can't fail, plus clone. And then I'm doing warp any map move, appcast.clone, exactly like they did, but with my cast. and that's going to get passed into my handler, which is the OMDB handler's media info. Before I go to the media info handler, I just want to make sure that you're aware that my warp path has a parameter, name. So OMDB service / name, and name is going to be a string. So my handler is going to have two inputs. It's going to have the string name, and it's going to have the appcast. And then coming to this file, which is my handlers, OMDB handlers. And in here, I have my media info, which, like I promised, has two parameters, name and appcast. So like they also did in the to-do example, I capture the lock for the cache. So local, I let mutable local cache, appcast lock await. And then, like I was saying earlier, a cache is kind of like a key value store. So what I did here was local cache.check, which we know what the check does. It checks the cache to see if a value for that key exists there. And here I'm just doing some logging. So some value. If it is found, I'm logging that it was found, and then I am let result IMDb score 30 JSON from value unwrap. So more or less what I'm doing here is I'm taking the value from the cache, which is a JSON object, and then I'm using 30 JSON to cast that, or I guess deserialize it to the actual object. And my object IMDb score is here, where I have derive, debug, serialize, deserialize, and clone. So name and score. So yeah, I'm making that into a result. I'm just pulling it out from the cache. And then I am using warp to reply. So okay, warp reply JSON, and I'm passing in a reference to the struct. So if the cache does not find the item, as in it was a cache miss, then I'm stating that I'm adding the name, this key, to the cache, which I can probably move down a little bit. It doesn't happen at that line. Anyway, here's my dummy function. The reason why it's labeled dummy function is because I haven't implemented the OMDB service yet, because I want to have a cache before I do it. Anyway, I pass in the name, I wait, I get the result, and then here's my local cache. I am adding the name and the result to the cache. So one thing you must be aware of is that the result of dummy function has to be serializable, because that is the trait constraint on the add for this item. As you saw in the cache file, add is going to return an option of cache result. So if the cache is full, then it's going to drop something. So if there is an item to be dropped, then I unwrap that item. I state that I'm dropping that item, and I move on with my life. And if there's nothing to be dropped, I don't do anything, and then I do my reply. So that's more or less the application. And I could run it real quick just so I can show you how the cache works. All right, so I'll open my terminal. Before I run it, I want to decrease the cache size so I don't have to run through as many examples. Let me do that real quick. So right now I have it hard-coded, but I'm probably going to have it come in via the config. So let's make this 3 for now, just so we can see how it works. Cargo run. All right, let me open the web browser. Start off with a hi. So this is the dummy function results, right? Where the name is name and the score is just high plus score. Later, when I implement the OMDB stuff, this will actually have the IMDb score. But that's later on. So I did high. Let me open my terminal again so you can see. Here we have an info message that says adding high to the cast, right? So let's put something else in there. Start with 1, 2, and 3 is going to be the fourth item, which should be over our limit. Going to my terminal again, we can see it in our logs, adding 1 to the cast, adding 2 to the cast, adding 3 to the cast, dropping high from the cast. So as you can see here, as the cast reached its capacity, we then started dropping the oldest items. And yeah, that's about it for what I wanted to show today. I was hacking on a project and I implemented a cast, and I was a little proud of it. I mean, it isn't the greatest in the world, but it's getting my job done. And I thought somebody else might appreciate or learn from this. Share that knowledge. Share that knowledge. That said, this is the end of the video. If you like the video, hit like, subscribe, yada, yada, yada. Outside of that, peace.